Hello, everyone, and welcome to the webinar on Drive Customer Centricity with Enterprise AI and Cognitive Computing. Before we deep down into the contents of this webinar, I would like to introduce ourselves. We are Stridely Solution. Stridely Solution is an QMS certified leading global technology solution provider. We are globally present in more than 18 countries and are constantly enhancing our span of services around custom software development, enterprise mobility solutions, and Internet of Things. We are trusted global partners offering services into SAP, IoT, RPA, Advanced Analytics, Microsoft Dynamics, and Microsoft CRM. I am Reena Parikh, AI/ML consultant and lead analyst at Stridely Solutions. I'm having 17 years of experience blended with academics and software services based organizations. I play consulting role in transforming useful data into business opportunities, and my areas of interest are image processing, deep learning algorithms, predictive maintenance technology in manufacturing, oil and gas industries, electronics industries, etc. Now, without taking much of your time, let us start with the agenda of today's webinar. Artificial intelligence and cognitive computing has an increasing importance in the interconnected digital world. Enterprise AI is a category of enterprise software that harnesses advanced artificial intelligence techniques, including machine learning, to drive digital transformation. The use cases for enterprise AI applications are unlimited. Today, organizations across every industry are deploying enterprise AI applications to address a broad range of use cases. In the coming years, nearly every enterprise software applications will be AI enabled. We'll look into some of the latest applications of AI and cognitive computing and how various industries are getting transformed by this phenomenon. We'll look at some use cases in various domains and also what are prospects of AI and cognitive computing. We'll also offer a checklist of foundation elements necessary for enterprise AI readiness. Now, let us have a just introduction to these terms, artificial intelligence, machine learning, and cognitive computing. If I have to give the perspective about how does a whole thing fit in AI, ML, and DL, so we have AI, artificial intelligence. Under that, one of the ways of doing AI is machine learning, and one of the ways of doing machine learning is deep learning. If you look at the time scale which has been shown on the graphic below, then AI is obviously caught on pretty much earlier and started maturing compared to the enabling technologies. So AI is not something that's happening now. AI has been around, and the enabling technology only caught on after 1980s, 1990s. There are certain myths about AI. So let us address this. AI will deliver magical results immediately. The path to AI success is hard and takes time. And not just because of the technology, you also need a strategic framework and an iterative approach. AI will replace human jobs. If you think that AI solutions might strip human from their jobs, then you are undeniably wrong. The reality is AI and human need each other. So AI is at its most valuable when it augments people's capability. AI implementation needs a huge investment. Well, in reality, there are a lot of smart tools which can be utilized to implement AI in various business procedures. AI algorithms are competent to process any data. So it's not possible for algorithms to make the decisions without human intervention. It requires pre-processing on the raw data, and technology companies will be the main beneficiary of AI. During the discussion on use cases, we'll see that there are many industries that may implement AI and can take benefit of AI. These are various machine learning approaches. The purpose of having this slide is not to go into the detail of these approaches, but to ensure that everyone of us are on the same platform. So depending upon the problem statement, the suitable approach is being applied. So one of the approaches is supervised learning. So supervised means here input data, output data, feedback, everything is known. Known in the sense it is labeled. So these algorithms have to deal with the label data, and that's why the major applications are like classification and regression, where you can see that I mean, classification means you can have an example of the image classifications or some fraud detection, or in regression that maybe like property estimation, some score prediction, etc. Unsupervised learning use deep learning to extract pattern through unlabeled training data. And here it has to deal with totally unlabeled data. And that's why the major application is like clustering. I mean, the problem statement in which you require segmentation, like customer segmentation, then market segmentation, or the applications like face recognition, image recognition, etc., where the patterns are to be extracted. And in between these two, there is a semi-supervised learning also, which deals with both the label as well as unlabeled data. The reinforcement learning, that's very, I mean, quite different from this labeled data algorithms. So here they are self-interpreting and learning in an interactive environment by trial and error using feedback. And the applications in this kind of approach are like gaming, then finance sector, inventory management, etc. Along with AI, we are using this term, the cognitive computing. So that's a very thin line or little difference between machine learning techniques or deep learning techniques and cognitive computing. The goal of cognitive computing is to simulate the human thought process. So using the self-learning algorithms that use data mining, pattern recognition, and natural language processing, the computer can mimic the way the human brain works. The applications are in the areas of business, including customer behavior analysis, personal shopping bots, customer support bots, diagnostics, etc. Now, let us move towards use cases which are adding the value to the business. And the first use case we have considered, that is improving the customer service or customer experience with the intelligent call routing. So that is applicable to the customer call centers or any service related industry. When a customer contacts your business with a question or issue, they expect fast and accurate answers. Instead, they are often put in a queue to wait for the next available agent. This can happen on any channel, whether phone, chat, text, email, or social media messaging. Frustratingly, that requires a customer to repeat themselves over and over again, and all this has negative impacts on the customer experience and contact center matrices. The better way to handle this kind of communication is with the intelligent routing. So let's see how does this work. Intelligent routing is fueled by data with information about the customer and from the question, knowing their intent, you can route that inquiry to the best resource available. Then how to get this kind of data? in order to know the intent of the question and regarding the information of the customer. So some data sources include initial discovery questions. So a chatbot may ask a customer what they are looking for before they are routed to the right agent, and after that, the chatbot, hand over the control to another chatbot. Customer profile data. So if you know who's contacting you, you can pull out the data from the CRM system to inform the routing. Customer journey data. What clicks has the customer taken leading up to the point where they reach out for help? And often intelligent routing happens through a chatbot interaction. The bot will assist the customer using natural language processing. That's an AI technology that understands the intent of the question without relying on the keyword matches. So that's very important. Just to searching the keyword, just instead of searching the keyword, it finds the context. So the customer can ask that question, and the NLP will parse out the intent. There are certain strategies or best practices that the organization can employ, like setting up the departments, folders, permission groups, then decide what CRM data is to be used for routing, because lots of data is there. So out of that, which is a useful data for this routing purpose, and set some cross-selling strategies at a suitable point. The another use case I have considered that is also from the natural language processing, and that is the literature mining. So whenever this word comes, literature mining, we are thinking of the researchers. During this COVID-19 pandemic that ignited scientists across the world, at that time, the data set, which is including full text as well as metadata, which is known as a COD-19, that was consisting of COVID-19 and coronavirus related scholarly articles, and that was optimized for machine readability. It was created and it was made available for use by the global research community. It contains over 128,000 papers. So it's not possible for any group of people even to read this much amount of text. So the need to organize a massive scale of the text data, it inspired the development of many NLP system. So how does the natural language processing help in this case? So apart from this mining, literature mining, it played role in information retrieval and question answering, misinformation detection, public sentiment analysis, etc. The another purpose served, that is known as a drug repurposing. Some drugs may look promising on a cellular assay, but shows little benefit in real clinical trials. So this kind of information can be mined from the biomedical literature and clinical trial reports. So NLP helped in this case, and that is again during this pandemic. That was with the help of the construction of the knowledge graphs. So knowledge graph is a branch of deep learning again, that works with a graph structured data. And then comprehensive survey was published, and that was looks at mining this knowledge graphs to find the approved drugs that may be suitable for treating the COVID-19. That this survey also considered the combination of the drugs, including this remdesivir. So many pharmaceutical industries are looking for such kind of solutions. The computer vision is another branch of the deep learning, which is associated with the image processing and cognitive computing, we can say. Let us have a look at the applications which belong to this particular field. Now, this is just showing the introduction, or we can say the architecture of convolutional neural network, because these networks are the deep learning network or deep learning model, which are universally used in almost all the computer vision applications. And there are variations of this architecture, considering CNN as the backbone architecture. Every year, these variations have arrived, like Google Net, VGG Net, Residual Net, Inception Net, Dense Net, all this. So you can see that every year these architectures are being evolved. Along with this, object recognition algorithms were also evolved, like RCNN, then YOLO, very popular, then single shot detector, SSD. This algorithms or architectures, we can say, they evolved through various hackathons. Those who are working in this field, they are aware about the hackathons which are being arranged, and researchers come with their architectures and participate into this. So all the applications which we are going to see further, so that includes the usage of this kind of algorithm. And the beauty of this algorithm is that the pre-trained algorithms are already available. So you just need to fit it on your data set, maybe still images, videos, etc. So the application of this computer vision in healthcare. So the image itself is indicating that the detection, classification of the lung cancer nodules in this CT scan images, that is possible. Then there may be mammographic images where the detection of the breast cancer is possible. Diabetic retinopathy images, that is also very emerging applications and very widely used applications. In case of this medical image applications, classification is not the only problem, but the prediction of the disease, that's also the important problem statement, because that's not a global function of the entire space. So you need to identify the region of the interest, I mean localize the region of interest in the image to understand the cause of prediction. And various operations like segmentation of the image, localization, classification, prediction, etc., are performed. And this data sets, like this mammographic images and then COVID CT scan X-ray images, and this data sets are readily available. Another application of computer vision is in industrial safety. We know that the top cause of manufacturing plant-related casualties are falls, then people getting stuck in the equipment, collisions, etc. The majority of these injuries can be prevented if the workers wear appropriate personal protective equipment like helmets, safety vest, gloves, then that safety goggles, etc. Now the rules are like the contractors have to enforce and monitor the appropriate usage of this personal protective equipment, PPE. Most production facilities already have a CCTV system installed on the premise, and a computer vision algorithm could use this live feed to detect the abnormalities. And in this case is also the training data sets are available, like the safety helmet data set, that's readily available, or you can collect the images and construct your own data set. Now, the next set of use case of AI is in, or applications, is in sales and marketing. So this is also very wide field, and it touches a large group of customers and directly related with the customer experience. Why should businesses integrate AI into their CRM tools now? If we take the case of the marketing applications, then AI-driven CRM can help you become more granular in your customer segmentation approach. With the help of intelligent algorithms, you can segment customers effortlessly on the basis of, say, demographics, purchasing behavior, their likes and dislikes. Then, if we talk about that lead qualification and then search tools, they generate leads from various mediums, various channels, whenever a prospective customer shows a buying intention. predictive analysis that prioritizes accounts and contacts based on their probability to engage and purchase. So let us have a look in such a use case. So there is a this depicts a rise of computer vision in retail industry. So one of the use cases is the use of the heat maps for retail. So let us see what is a heat map. A heat map is a tool used for visualizing the strength or magnitude of an occurrence. Examples of heat maps include maps which are depicting population density, traffic flows, or user visits to the different parts of the web page, etc. So there is a concept of hot and cold areas based on the colors, so which are used to illustrate the areas of high and low activity or flow or density, you can say. A typical heat map in a retail store is a shop image which is overlaid with a map showing the most or least visited parts of the store. So they provided a detailed insight into the activity of the people within the departmental store. Cameras installed at various locations in the store take images that are processed through a computer vision layer, which detects and tracks the people and their movement. These heat maps may have many benefits and applications like smart store layout and design. So obviously the areas visited often are made more spacious and less congested. Then advanced product marketing, knowing which areas of the store are more popular, it helps retailers to decide where to place items and capture the customer's attention. Then efficient staff placement, optimize shoppers waiting time. I mean, during the course of the day, when there is a more density of the customer, population of the customer, then they can the retailers can plan their labor and maintenance costs can be optimized accordingly. The another application in retail is end-to-end product information management software. Uh, we will call this as a smart PIM. This is a AI-enabled PIM. So in this smart product information management software, the customers can take a photo of the product, and the computer vision software will help detect or identify that product and provide the detailed information about it. Now, the detailed information about the every item are like the basic information, like such as such as the attributes of the item, like color, dimensions, cost, warranty, supply information, the retail outlet information, etc. So along with the basic, some contextual information of that product can be also merged from various platforms. So a smart product information management system, it manages not only the basic product information, but also its context using the centralized software system. So when incorporated into a PIM system, AI, artificial intelligence, can create an effective and error-free data onboarding process. The another area where we can apply this AI, cognitive computing, computer vision, natural language processing, deep learning, all this application is the supply chain and logistic. So this is such a vast area that it would not be possible even to touch upon all the applications, in this limited period. So here, just few applications or few areas are introduced which are benefited by AI, like demand forecasting, then supply planning, then customer service bot, damage detection or visual inspection, route optimization, which is related to the logistic applications, etc. So if we want to take a use case in the from let us say manufacturing, that's also part of the supply chain. So we can take the example of the predictive maintenance. Uh, Predictive maintenance, it drives industry 4.0 along with IIoT. Now, everyone is aware about the IIoT. There are lots of sensors, large number of sensors are there, and these sensors are being monitored, and their behavior is estimated, and based on that, the future system failures can be identified, and depending upon the failures, the plant manager can schedule the maintenance in advance. So that also helps in prediction of the remaining useful life of the equipment. That's a very useful application nowadays. Uh, this is to avoid or minimize the downtimes. So minimizing the downtimes, that's significantly increasing increases the ROI of a plant. Then if there is some abnormality in the behavior of sensor or equipment, then that can be detection. So that is also being done by anomaly detection. And as a schedule, a maintenance schedule has been prepared in advance. So optimization of this periodic maintenance operation is also possible. Uh, Before this predictive maintenance, there is, I mean, some still the industries are using the preventive maintenance. So that's the difference between the preventive maintenance and predictive maintenance. In preventive maintenance, it relies on visual inspection along with the routine machinery health checks, while the predictive maintenance will tell you that what will happen in future, what kind of failures may occur in the machine, so we can take the action ahead of the time. And for this purpose, the real-time and historical data is to be utilized with the help of the sensors from various machines. So these are several industries which are benefited by AI. So not only the technology industries, but you can say that manufacturing, retail, and even agriculture, aviation, so fashion industry, online shopping. So all these industries are utilizing AI now. Now, let us talk about this enterprise AI readiness. So here, some checklist is given in order to check that what is our readiness to employ enterprise artificial intelligence. So we should ensure the clarity on the business applications and the relevant use cases. The choice of the use case is very critical. And which particular application we are targeting, so that will lead to the success of the AI applications. Uh, the industries have to confirm with the stakeholders that AI is not a single technology solution. Then relevant subject matter expertise should be available to scale it effectively, because it is touching many areas where it requires the subject matter expertise. Then enterprise information data, this should be readily available, and it should be in a proper form in order to have the successful AI implementation. Along with that checklist, we have also some status check for the organization, so they can see that where they are in their journey, in the journey of implementing this AI or ML or deep learning. Uh, Whether you are using some experimenting models and they are in development phase only, or you have a handful of models in production, and but you're manually deploying these models. Manually deploying means by writing a script. You have tens of models, and the semi-automated process you're using, or you have the hundreds of models, but these models are depicting the repeatable processes, or you have thousands of models in production, and you have the systematic MLOps. So based on this also, you can check that where you are in this journey. Based on the tools which we are using for this AI implementation, that can also check your status in this journey, like whether you are using Jupyter notebooks or you're using open source ML frameworks, or cloud, you're using this cloud ML platforms, or you have the explainability platforms. There is a very little use of this explainability platforms, or you can have the integrated ML platforms. So these are quite systematic platform. So depending upon which tool you are using, so that also decides what is the maturity of the organization. And here there are certain success metric that it measures the we should measure or we should consider the effectiveness and not just accuracy of the model, because accuracy of the model, it's quite a mathematical term. And that can be improved by retraining model with more and more data, but how it is effectively employed in a particular application or in a particular business. So that is more important. The improvement in the response rates. Initially, your customers may be engaged with you, but then how proactively they are providing the response. So that will also measure the success rate. Number of new signups from the initial signup, whether you are able to generate some new signups, user retention, and A to B testing success relative to the other models. So these are all the success metric. So here we have reached to the end of this webinar, and I would like to open the question answer session. So I would be happy to answer the questions. And in order to answer the question, let me unmute you people and allow you to speak. I have unmuted all the participants. So if you are you cannot speak, then you can check your audio button and you can self unmute yourself. Or you can also write the question.
Okay, this is Anthony Seward here from Baystone. I've got a question. So when we're looking at things like the call center artificial intelligence tools, do companies typically build that themselves, or do they outsource like through different companies? Or are there companies out there that could have tools like this that a company could probably purchase and use on their, for example, Talkdesk?
Mm-hmm. Yes, like in case of the call center, so we can apply this natural language processing, and in this case, you can know the intent of the question. So basically, in this case, is multiple chatbots are being employed. Initially, one chatbot will handle the inquiry-based questions, and based on that, it will rely the control on the other chatbots. That will act as a systematic framework in case of the customer call center. But the important thing is to manage the data, because there are large amount of the data, so that would require a specific framework to handle the large quantity of the data.
Okay, thank you.
I hope I have answered your question. Thank you.
You talk about within the manufacturing space. So within the manufacturing space, there are multiple companies that operate. Specifically, something around maybe an industry which is into the interior designing, right? Something like plywood, something like setting up the entire interiors, right? Those kind of companies, what can AI do for them?
Very good question, and this is an area of my interest also. I would like to give you one example for, say, interior designer company. In after manufacturing, say, you want to know the choice of your customer, right? See, for example, plywood is available in different shapes, and there are different patterns onto that. At a moment, you don't have all the choices available available, I mean manufactured. But what you can do, there are algorithms like which are known as GAN networks. They are similar to this CNN, which I talked about. I mean, basically they are the deep learning algorithms. So they may generate on their own various fashions of or various patterns of this plywood, along with the color, along with the different pattern, and you can show it to the customer. And based on what is the choice of the customer, I mean different customers. So based on the volume of that, you can plan your production accordingly. So that is about that. Along with say plywood, you can have when you employ the cross-selling strategy. So along with say plywood, you want to give some lighting facility or something like that. So that also you can show, because the GAN network will automatically generate that pictures that will show the various arrangement of the furniture, lighting, which are not practically existing. So that's a branch of the deep fake networks. I hope I have answered your
Okay.
question.
Yeah, you did, but I think one of the things around plywood is sitting around a specific kind of boards that get manufactured, right? So
Yes.
one is about choice, yes, but then which is taking it too far away in terms of then redesigning it for because that has to be then at a very large scale in terms of the size of the organization. Something like a Greenply or somebody who could actually do that, but there are a lot of players, and because the market is so unorganized as a sector, what things at a minimalistic level most of the companies can undertake using AI is what I'm actually intending to see.
Okay, so your question is for like small scale industries,
Yes,
which
yes,
are,
yes.
yeah. Okay, so at small scale industries, if you are targeting the marketing of this particular thing, then you can have your you can employ say again this image processing algorithms, where they can have the various images of the plywood and like that. Or if you're looking while you are manufacturing this, then in the manufacturing industry itself, the type of the wood, when you are buying the raw wood, then what is the quality of that wood. So all these applications are being covered by the deep learning. So it will check the quality of the wood, then type of the wood. So all these things can be also checked by this algorithm. So of course you're asking, I mean there are various aspects, I mean whether you want to employ. So that is about selecting the use case, whether you want to apply on floor, I mean during the manufacturing, or you want to target the market, you want to target the customer. So that depends upon the application.
Sure, thanks.
Okay, I can see some of the questions ready in the question box. Uh, there is a question from Shyam. Hi, can you provide few use cases for explainable AI, please? Oh, yes, definitely. As I say that this explainable AI, like Lime and Shape, these are not widely used, right? Because people are thinking that they are, I mean, they should, I mean, majority of the people are going for cloud-based application and some integrated platform. But these are also some open source library and which are available in by the scikit-learn and all. So you can have you can using this Lime and Shape libraries. What you can do, you can carry out the data analysis, and along with that there is a generation of the graph is also possible. I mean, say for example, you are going to do some kind of analytics, right, where you need to generate the graphs which are showing the, say demographics of people into certain region and all. So along with that processing on the data, it will also generate the graph. So no separate code has to be written for the graph, because there are many fancy graphs are available, or you don't have to use a Power BI or Tableau or something like that. So that is also readily available. So depending upon that, you have to select whether you will go for that line or shape.
Hi, I have a follow-up questions to that. Is that okay to ask?
Yes. Yes, please.
Especially when it comes to enterprise AI, what I'm struggling with it is for the fact that, take an example of demand forecasting, right? Especially for sales and finance folks. And one of the things that I'm trying to help them with is that you do a demand forecasting today, bottoms up or top down. You do it the way you do it today. And if you use, let's say it comes up with $1 million as a forecast for Q1, and then the AI model comes up with, let's say, $850,000 instead of $1 million, we need to be able to explain to the sales management and the CFO what is the gap. So have you or done any implementation where you're able to bridge the gap and tell them that this is the real difference between the manual process that you have today or whatever process you have today versus what AI came up with, so that they understand and trust, have gained some trust in that model. Otherwise, they'll say this is garbage, sort of a thing, and throw it away. So helping them bridge that gap between both the models and telling them this is the real difference is that is the key part when it comes to on the financial side, right? Because you use the demand forecast to guide the street. So that is very important to understand, what is the delta. So my question to you is is that something that you have experience implementing with, or have some ideas of how to build a bridge?
Uh, really a great question, because it happens, because when some things are easily predictable, then the management will definitely say that, then why to implement this? You can do on your own, not by any analytics software, you can find it out, but see, it depends upon the market. So if you are having a very very huge market and you are touching upon the customer, so it is nowadays the AI models, maybe a deep learning model or machine learning model, they are not relying only on their on the frequency of buying or purchase, but they are also considering some context-based information, like how they like, dislike, and that information it is coming from omni channels, how many clicks they have made. So all this analysis is being taken. Then have they ever interacted with you in terms of the chatbot? Then what are their feedbacks? So analyzing the numbers, that may be possible, but analyzing text and identifying that what they want to say. So it's not like the sentiment classification case maybe, but you can also map the service history of the customer, the service which you have provided on your own. Say in some case the service may be delayed or not, and what was their reaction at that time, and now after a month, whether the customer go for this or not. So there is interconnection, and that comes under the reinforcement kind of architecture. So this kind of very small details are being learned, and if your market, the targeted market, is such a large market, then you can definitely afford this kind of models. If the things are easily predictable, then yes, AI is a model will be a garbage. So we have to consider such small things, and that will make the model smarter and smarter, and more amount of the training data it will have, because there are large number of customers. So identifying their intents or contents or their feedbacks, their service histories, everything, taking into account everything, processing that data, because all this data should be also in the machine readable form. So that's not possible by the manual efforts. By the manual efforts. Yeah, if you have to just count the frequency of their purchase and find out the demand, then that's a different case. But if you really want to go into detail, and if you really want to apply this as organization strategy, then you can go for this kind of models, AI models. And there are certain tools. It's not like that it is always very, very expensive. So there are certain tools which are readily available, and they can provide you the customized models, which are sometimes, I mean, they're easy to be deployed also sometimes. Yes, so that's my opinion.
Thank you.
I would like to add something to that question earlier. It's kind of the same experience here. So like, let's say we're creating a customer churn or a customer attrition model, AI, like a neural network model, to help understand the business, or to kind of predict like customers are leaving, and we want to catch them before they leave. Once we build the model and deploy and everything, and then the business comes and asks us, okay, so what is the conclusion here? Why are customers leaving? It is extremely difficult to explain based on a neural network what is the main driver of like churn. You know what I mean? So I'm just want to see from your experience, how would you explain what drives churn to the business?
Yes, so customer churning. So if you look at the normal use cases, then it just depends upon the frequency of buying. That again, when the customer have started associating, and when the frequency of association is increasing or decreasing, so like that. But finding a new customer, instead of that would be, and retaining that would be difficult in comparison if you try to retain the existing customer. So in customer churn also, we can take some small details of the customer, and we can identify the behavior. And what we can do, if the frequency is being decreased, then identification of that in advance, that should be association with some retention practices. Say for example, you're offering them something like say cross selling. You're providing some offers. You are identifying that customers, pulling out the data, and based on that, also you can also find out that what are the other things that they are looking for, and why they are leaving you. So based on that also, you can offer, you can provide them offers, so such that they will come back and associate with you. So that's why predicting it ahead, and along with that, using all other data of the customer, so that would retain the customer. So that is the importance of the customer churning.
Okay, thanks.